Hi everyone, welcome to the channel Kemi Krishna, and in this video we shall start up solving the questions that are asked in recently happened Karnataka state eligibility test for the appointment of assistant professors. Okay. So here I have taken the first question which is asked in the question paper. Which of the following is not isoelectronic with krypton? We know that isoelectronic in the sense these are the species that will be having same number of electrons, right? So here the element given is krypton, which is having an atomic number of 36. So number of electrons is 36, and now we have to check among the four options which is given, which is not going to have the number of electrons equals to 36. Option number 1 is rubidium, which is having an atomic number of 37. Okay, and here they have placed one positive charge that indicates lapse of one electron. So number of electrons in rubidium plus will be 36, which is isoelectronic with krypton. So this is not the right answer. If we go for the second option, that is strontium is given, and strontium is having an atomic number of 38, but they have placed a 3 plus, okay, so here they have placed 2 plus positive charge, means loss of 2 electrons. So 38 minus 2, once again we are going to get 36 electrons, which is also once again isoelectronic with krypton. And third one is selenium, which is having an atomic number of 34. But here they have placed 2 negative charges, right? So there will be an add up of 2 electrons. So 34 plus 2, it will be 36. And the last option, that is arsenic. Okay. Arsenic is having an atomic number of 33, and the charge present on arsenic is 3 plus, so there could be loss of 3 electrons, so which is going to have 30 electron. So krypton is having 36 electrons. The first 3 options are exactly isoelectronic with krypton, but not arsenic 3 plus. So the correct answer for the question is option D, which is having 30 electrons. The second question is the element having the highest first ionization energy is. The 4 options given are gallium, potassium, bismuth and arsenic. And now we shall see the gallium, which belongs to group number 13, which is having a general outer electronic configuration of Ns2Np1. There are 3 electrons in the outermost shell. And if we come to the second option, that is potassium, which is belonging to the group number 1, which is having a general outer electronic configuration of Ns1. Bismuth, the third option is bismuth, which is belonging to group number 15, which is having a general outer electronic configuration of Ns2Np3. Arsenic also belonging to group number 15, which is once again having an outermost electronic configuration of Ns2Np3. So these two are the ruled out cases, because Ns1, it is having the this is having only one electron in its valence shell. Removal is very easy. And gallium belongs to group number 13, which is having one unpaired electron. Removal is easy compared to these two, wherein in NP shell we are having exactly half-filled configuration, which gives extra stability for the element, and that makes more ionization energy. But between bismuth and arsenic, which one could be having the greater ionization energy? In strictly speaking, first ionization energy. If we go for the order of the elements that are present in the group number 15, nitrogen, phosphorus, arsenic, antimony, bismuth. So this is the order of the element. As we know that as you move down the group, ionization energy will decrease. So bismuth will be having the least ionization energy compared to that of arsenic. So the correct answer for the question is option D, that is arsenic. Next, the question is, among the following, the amphoteric oxide is. As a word, amphoteric says, this is the one that can having the capability of forming both acid as well as base. It can react with both acid and base. That is the actual meaning of amphoteric. And here you can observe we are having 4 options. One is the sodium oxide, aluminum oxide, magnesium oxide and chlorine oxide, right? So we know that the S block elements, the elements that are belonging to group 1 and group 2 are the one which can easily dissolve in water and can readily produce corresponding hydroxides. So all the alkali and alkaline earth metal oxides means the elements that belongs to group number 1 and group number 2. All the oxides of alkali and alkaline earth metal oxides can readily form basic oxides. Okay, and the elements that are present towards the end of the P block, that means the one which belongs to halogens. Okay, so halogen oxides are the one that can readily form acidic oxides. Means when they dissolve in water, they readily produce acids. But the elements that are belonging to the middle of the periodic table, means the element that are present in group number 12 and group number 13 especially, okay, the oxides belonging to group number 12 and group number 13 are the one, especially the aluminium as well as zinc. These oxides are the one which shows amphoteric behavior. So based on this criteria, sodium belongs to group number 1, magnesium belongs to group number 2. So these two will form basic oxides. Chlorine belongs to group number 17, which is an halogen oxide, preferably forms acidic oxide. Aluminium oxide is the one which is amphoteric in nature. So the correct answer is option B. Next question is, the total number of bond pairs and lone pairs in H2SO4 molecule respectively is. Here the four options: 8 and 6, 8 and 0, 8 and 8, and 6 and 0. In order to count the total number of bond pair of electrons and lone pair of electrons in any molecule, we are supposed to well aware of the complete structure of its molecule. That means the Lewis dot structure is supposed to be known. Now let us write the Lewis dot structure for sulfuric acid molecule, so thereby it is easier for us to predict or to count the number of bond pairs and lone pairs. In case of sulfuric acid, sulfur will be at the center and there will be 2 oxygens bonded with pi bond, and remaining 2 oxygens and 2 hydrogens are in the form of OH. So this is the complete structure of sulfuric acid molecule. So sulfur belongs to group number 16, 1, 2, 3, 4, 5, 6. All the 6 electrons are involved in bonding. Oxygen also belongs to group number 16, but only 2 electrons are involved in bonding, so remains with 2 lone pairs. Here also the same thing, 1, 2, 1, 2, and here also. That's the complete dot structure of sulfuric acid molecule. Now let us start off counting the number of bond pairs and lone pairs. So here you have 1, 2, 3, 4, 5, 6, 7, 8. So we are having 8 bond pair of electrons, and the number of lone pairs are 1, 2, 3, 4, 5, 6, 7, 8. So we are having 8 lone pairs. So we got the answer, and the answer for the question is 8 and 8. The right answer is option C. Next, the geometries and hybridization. So we know that geometries and hybridization schemes of the compound ethylene and methane are. So in order to account for the hybridization as well as the geometry, we need to know the complete structure of a material, right? So the first material given is ethylene. So ethylene is simply nothing but ethene, right? So ethene is an unsaturated compound which is having a structure of CH2 double bond CH2, right? So in order to find out the hybrid state of a carbon atom, just we need to count the number of sigma bonds present around the carbon atom. The total number of sigma bonds present around the carbon atom will give you the type of hybridization that the carbon atom is involved. Say if carbon is surrounded with only 2 sigma bonds, then the carbon will be in sp hybridization. If the carbon atom is surrounded with 3 sigma bonds, then it is involved in sp2 hybridization. If the carbon atom is surrounded with 4 sigma bonds, then the carbon is in sp3 hybridization. This is the criteria we can follow to find out the hybrid state of the carbon atom. If you come to the case of ethene, this is the carbon, the 2 hydrogen atoms are surrounded with 2 sigma bonds. So here between 2 carbon atoms we are having 1 sigma bond and 1 pi bond. So to account for the hybrid state we need to count only sigma bond. So here is 1 sigma and this is pi, so 1 plus 2. There are 3 sigma bonds present around carbon atom. So the carbon atom is in sp2 hybridization, and the same thing will apply for this carbon too, because this carbon is also surrounded with 2 hydrogens, so there are 2 sigma and this is 1, to which the carbon is attached. So each carbon is surrounded with 3 sigma bonds, so they are in sp2 hybridization. So if any material is involved in sp2 hybridization, the geometry of the material will be trigonal planar, right? Then the second material given is methane. So methane, which is having the structure CH4. Carbon is surrounded with 4 hydrogen atoms. Obviously, there will be 4 sigma bonds around it. So the hybrid state of the carbon in methane is sp3. So the geometry will be tetrahedral. So the option will be, first the material asked is ethylene. So sp2 planar followed with sp3 tetrahedral. So sp2 planar and sp3 tetrahedral. Option C is the right answer. The next question is, the total valence electrons in an organometallic compound is given in that the central metal atom is ruthenium. So we are having a totally 3 ruthenium atoms. It is a multi-nuclear organometallic compound, and the options are 42, 54, 45 and 48. So now we need to know what is the total contribution that each ligand is going to give towards the central metal atom or central metal ion. So here they have given eta 5 cyclopentadienyl. So the ligation indicates the hapticity is exactly equals to 5. So each cyclopentadienyl ligand will give 5 electron contribution, and there are totally 3 such cyclopentadienyl cations. So 5 into 3, 15. And there are carbonyl ligands are there, and each carbonyl ligand will give 2 electron contribution, and there are 3 such carbonyl ligands. So 3 2s are 6 electronic contribution. And we are having ruthenium, which is having an atomic number of 44, which belongs to iron group in its periodic table. So the number of valence electrons in case of ruthenium is 8. Okay, because it is having D74S1 electronic configuration. Okay, so totally 8 electrons are there in ruthenium. So 8, but we are having totally 3 ruthenium atoms. So 8 3s are 24, right? So ruthenium is going to give 8 electron. So 8 3s are 24. Am I right? So totally 20, 30, 35, 41 plus 4, 45. That is the total number of electrons in this complex, which is there at option C. That is the correct answer for the given question. Fine. So if you see any question paper both in your CSIR NET as well as in any state level eligibility test examination, one question will be mandatory on the concept of boranes. So we need to know what is the way actually to find out the structure of a particular borane material. Okay. So look, BnHn plus 2. If any borane is belonging to this class of a material, then that will be called as closo. If the material belongs to BnHn plus 4, then it will be called as nido. If the material belongs to BnHn plus 6, then it will be called as arachno. Then if the material belongs to BnHn plus 8, then it will be called as hypo. So these are the classes of borane material: closo, nido, arachno and hypo. And here the material given in the question is B4H10, which is called as tetraborane, and we shall observe the value of N over here is 4. So in order to get the 10, how much we are supposed to add? 6, right? So obviously B4H4 plus 6, Bn Hn plus 6. So it belongs to the category arachno. So correct answer is option C. So very easily you can score a mark in any competitive examination if you are well thorough with this particular concept, that is boranes. One of the important topic in any competitive examination, especially the CSR, NET and state level eligibility test, is the topic of nuclear chemistry, especially the artificial transmutations. That means the element bombarded with any of the projectile. It can be proton, it can be deuteron, it can be neutron, or it can be electron. So here we are observing the bombardment of plutonium-239 by a neutron, so that we are getting ejection of 3 more neutrons. So it is neutron, 3 neutron type of artificial transmutation. And here we need to find out the value, what is the element that is going to produce X along with selenium. So simple thing, in order to find out the answer, just you look over. Law of conservation should be matched. 239 plus 1, 240, 94, right? So let me take it as X. So totally how much I am getting? 91 and plus 3. So 91 plus 3 is 94. And here I have 94 and there is expulsion of 38. Right? So 240 minus 94. How much I am going to get? 240 minus 94, I am going to get 146. 94 minus 38. So 94 minus 38, we will be getting 56. Okay. So 94 minus 38 is 56. 240 minus 94 is 146. 56 is the atomic number of barium with mass value 146, and that is the element which is produced as X, which is there at option A. That is the answer. So each and every examination will definitely give one question on either fission reaction. So do remember. The next question is the product of Avogadro number and electron charge is. The options given are Boltzmann constant, Faraday constant, Rydberg constant and rate constant. Boltzmann constant is simply indicated with the K, and Faraday constant is F, Rydberg constant is RH, and rate constant is obviously K, right? And here first we need to know which are the components given, that is Avogadro number and electron charge. Avogadro number, that is Na, which is having 6.023 into 10 power 23. Electronic charge is 1.602 into 10 to the power of minus 19. So 10 to the power of minus 19 and 10 to the power of 23, and on product 6.023 into 1.6, right, into 10 to the power of minus 19 into 10 to the power of 23. So if you have taken the shifting of the point, so just let me take in this way, 16 into 10 power minus 1 into 6 into, so 19, 20, 21, 22, 23, 10 to the power of minus 4, and here I have 10 power minus 1, so let it be 10 power minus 5. So 96. Sorry. So let me take it as 16 into 10 power minus 1. So let me take it as only 6 into 19 minus 23. You are going to get 10 power plus 4, right? 19, 20, 21, 22, 23. So minus 1, obviously we are going to get only 3, right? So 16 6 96. So 3 zeros, 96,000. So approximately it is equals to 96,500. That is simply nothing but a Faraday constant. So correct answer is option B. So those are the questions that I have taken for this session, and in the next video we shall try to solve some important questions that are asked in KSET examination 2021. Thank you very much.